All right, so today we are doing the descent, and uh, uh, Ayana has shared her attempt of this puzzle with us, so that's what we're looking at right now. And so walk us through what your plan is, Ayana, with how you want this code to work.
Um, so I was trying to define the mountains of in order like that it was given to me. And then I was trying to print the targets of the height. So I defined the min as like the lowest mountain as two. And then the max is less than nine. And then I was trying to give my variables a definition of where I wanted to hit. So certain integers, as in zero, which would be which would be seven, and the tallest one would be zero. Um, and I don't know if it's like a spaceship or something that's coming down, and this is mountain zero. But this is a mess. This is a mess what I wrote. So
Okay, okay. And if you scroll down a little further, it looks like you have your inputs. This is where you're getting the input from the computer. So you have for I in range 9, you're getting the mountain heights, and those are integers. So it doesn't look like you're parsing that. That's one of the issues that we're going to want to address, because what's happening is you're assigning that variable mountain h, but you're not really capturing it anywhere. So it keeps overwriting that same variable of mountain h, but there's nothing in the for loop that's capturing that information and putting it into like a list, for example. So we're you have and then you have
oh,
a
okay,
yeah, and then you've got a function name, mountain h, which sort of collides with that variable. So that's something that we're going to want to address as well. Um,
so can I just get rid of this since I have my own like change
well,
this around?
so it looks like you're trying to kind of hard code an answer of this, ignoring what information the program is feeding you. So
Mm-hmm.
there's a like a referee program running in the background that's giving you the information about which mountain heights are, what height each mountain is. And
Uh-huh.
if you erase that input, then you're pretty much ignoring the information that's being given to you, and you're just giving a solution that will only really work in one case, and every other situation it won't be working. So we don't want to hard code the solution. We want to be able to take into account the information that they're going to be giving us.
Okay.
So and then as we talked about before, you wouldn't want your functions. You're defining a function here within the while loop, and you wouldn't really want to do that. Your function definitions should come before your game loop, and your game loop is going to be calling those um, throughout the loops. It's going to keep calling functions, but you don't want your functions to be embedded within the game loop itself. So
Take
I'm going
this
to go
and put
ahead.
it. Oh,
Yeah, that should, whatever you're doing, that's a function definition that should come before the while loop. So I'm going to go ahead and show you.
sure.
I'm going to share screen, and I'm going to kind of show you how I would go about solving this, and
Okay.
so we can walk through this descent together. So the descent, there it is. All right. Um, so I would like it if everybody went to Codingame and found the descent under puzzles. You could just do search for the descent, DESCE. If you just type that in, it'll recognize what you're looking for, and it'll come up. You can see that the community success rate for this one is about 54%. So about half the people that try this are able to get it. The difficulty, it says, is easy, but if you're a beginner, easy is maybe relative here, right? You can see that it's one of the easier problems on Coding Game, but it still is challenging if you're just starting out. So we're gonna go ahead and solve this together, and actually, I'm gonna I'm going to reset the code. So this is what it gives us to start with. So it says, while true, for I in range 8, it's going to give us the mountain heights. And then we're going to print, and the default is 4. So let's go ahead and print this. And so it's going to zap 4. It's going to reduce that mountain right there. And it's going to keep on doing that. You can see it slams into this tallest mountain because each time it descends one level, your ship descends one level. And so unless you are, if you're always zapping 4, then you're not going to be taking care of the tallest mountain. And so that's going to be a problem because you're going to hit that mountain when you reduce your level. And so what we want to do is we do want to capture these mountain heights, right? We want to be able to get these mountain heights. And that was one of the issues with your code, is that you weren't parsing it. You weren't capturing that data. So each game cycle, it's going to be telling us the mountain heights, and we need to find which of those is the highest mountain. So there's a variety of ways we could do that. I think I'm going to probably want to use a list. So or we could use if-then statements as well. We could use conditionals, but we do have to process that information somehow. We have to have a way of taking in what information they're giving us and then processing it and then basing our answer on that. So we don't want to hard code an answer. All right. So what we could do is maybe identify what the highest mountain is. So we could say like index equals maybe like -1. But we'll start our index as -1, and we'll only alter that index as we get information here. And then the highest mountain is we could start that at maybe like we could start that at -1 too. Doesn't really matter, but we want it to be smaller than the highest mountain, because what we want to do is if this mountain height that we just received here is if mountain height is greater than the highest mountain that we have recorded, then we want to replace, that's when we want to overwrite this highest mountain. So then highest would equal mountain height. And then index, what do you think we're going to replace the index with?
Would it be the height of 0? Or
It's actually going to be the I, because what we're iterating over, see, we're going from I in range 8. So it's giving us those 8 mountain heights. And the index, see, this is mountain 0, this is mountain 1, mountain 2, mountain 3, and so on. And whichever one is the highest, I want that to be recorded as my highest mountain. So I'm logging that my highest mountain is, it's going to be constantly iterating over these 8 mountains and checking to see if each of the mountain, like in this case, mountain 0 is the highest. So let's follow through what happens here. So when I is 0, that means the index is 0. It's going to give me a mountain height, and that mountain height is 9. And so the highest is going to be replaced with the mountain height, and the index, I want that to be, because it's mountain 0, I want that to replace. So I'm going to put index equals I. So it's going to replace the index, which I just declared up here as being -1. It's going to replace that index with a 0. And so that's going to be our new highest mountain. And then we're going to go to mountain 1. So mountain 1 has a height of 8. So because that's lower than mountain 0, we're not going to do this replacement here because it says if mountain H is greater than highest. Well, it's not. So we're not going to do this. We're just going to keep going. And it's going to, as it cycles through all of these mountains, you're not going to get to a mountain that's higher than that original mountain 0. And so once we have the index, we could just print that index. And it should work here. So let's try that. All right, so it works if it's descending mountains. Now let's try if it's scattered mountains. All right, so you can see that whichever one is the highest mountain, that's the one that it's going to zap. And then there it goes, the highest mountain again. So it's only identifying which one is the highest mountain. And the way to do that is by comparison with a starting point. So I'm just starting it as the highest as being -1. And any mountain that's greater than the highest one that I have recorded, it's using this conditional statement right here. And it's handling that. So actually, I think that is pretty much all you need to do for that. And that's why they called it an easy challenge, because you really only need this conditional statement here in order to solve it. So you just declare these two variables and then use this comparison for the if statement, and that captures whichever one is the highest. So before let me comment this out. So if you write 3 quotation marks, this comments it out. So, you can just kind of ignore this. So before, when I just had the mountain heights, it kept feeding the mountain height, but I wasn't doing anything with it. I wasn't putting it anywhere. I wasn't capturing which one was the highest. So I needed this piece of code right in here in order to get that done. All right. So it says while true. So in other words, while there are still mountains to shoot, that's what that while true means. While the game is still going and it hasn't ended yet, this is what it's going to keep cycling through. And it's just going to print the index of whichever one is the highest. That's all I want it to do.
Okay, so I was trying to alter the conditions of what was already given to me. Like I was
Yes. Yes. Yeah. You were kind of
okay.
ignoring what they were giving you and we're trying to do something different. And I can show you how uh how involved my initial attempt was at solving this. Let me see if I can get um my descent. Where is my descent? The code for that. I know I saved it. I know I saved it somewhere. Oh, yeah, I think it's under here. Descent. Okay. So uh, the first time that I tried to solve this, um, I was using indices. And this is another way to do it as well. Actually, I don't think this was the first. I think I had some like weird attempts, sort of like how you did, where it didn't really take me down the path that you actually needed. I was going all over the place. But
Okay.
this is how I did it in another situation where I was appending to a list, and then I was finding what the max of that list was and identifying its index, and then that's how I use the index. So this is sort of more of a roundabout way when using lists to get there. And then yeah, I named the variables a little bit different, but like the overall process of how I later solved it was the same. So there are really direct ways to solve these problems a lot of the time, and um you'll get those as you keep going through and keep seeing more solutions and seeing how people do it. And you are going to get better and better as time goes on at just going directly to the answer, but you have to sort of see some examples of what that looks like first before you know what to look out for. So do you guys have questions on this challenge or on how I solved it. Or maybe I should phrase that differently. What questions do you have? Because I know that's like a lot of new stuff here.
Okay. I had a question.
Mhm.
If you could show me the attempt you just did.
This one right here. Yeah. All right.
So I remember when we did Thor, all of the
Mhm.
conditions were given to me initially. So I didn't really know how to create my own. So for
Mhm.
this, Python like understands like the index like this. Like I don't need a special variable for that. Like it already understands that, right?
You
Do
mean
you,
this index right here when I declare it?
yeah. Oh, you declared it. Okay. Okay. So you had to define it.
Yes, I defined that there is a variable index, and a good habit to get into, which I'm not necessarily in, is to declare what that variable is. So um, that way you're letting Python know, and you're letting any programmers know I'm declaring a variable. It will be an integer, and I'm assigning it the value of -1. So Python
Okay.
actually lets you do things that if you're doing it in pseudocode, you would have to you actually have two steps in the process, but Python condenses that to one, which is declaring a variable, declaring that there
Mhm.
will be a variable, and then assigning it a value. Those are technically two different things happening there in one step.
Okay, because I thought I had to type define. Is that also okay? Or is it
So
just
so
like that's
DEF is for functions. So um
okay.
you could do a function of like is highest or something like that.
Okay. Okay.
And then you're going to give that a variable, and you could say if n is greater than, or if you would actually want two things here. You would want like n and then highest. And then if n is greater than highest, then um, you would return um, highest, else return n. So you could do it like that, and then that way you're just always going to be getting whichever one is the higher between highest, your previous highest or the new n. It'll just return the highest of those values. So that's another way that you could sort of have get the same kind of thing here. So I could rewrite this as highest equals is highest. Um, and then it would be mountain h, that's the new n, and then highest, which is itself. So let's see if that works. I might have messed things up. Yeah, that that kind of messed things up. Okay. So what's my error message with that? Um, let's see. You crashed your spaceship. So why did it crash? I think I'm probably using the same name here, and that's not a good thing. Um, highest equals is higher than. Uh, yeah, I'm actually not sure why it's breaking now. But you can see that if you're using functions, there's definitely risk of uh doing some unintended stuff. But functions are very useful because they allow you to recall the code over and over again. Keon, how you doing, man?
I'm doing great. Sorry I was late. I was doing some homework with John.
No worries. We were just talking about Descent, and I just altered some code here, and don't know why it's breaking my program. But all right, so let's do another one. Let's do Thor, because I know um that's probably going to be within the realm of possibility for a lot of you. Um, it's one of the earlier puzzles. I'm
I
not
never got
gonna
this up too.
uh here, I'm gonna reset my code here. I'm not gonna solve this one for you. I want to have you guys try to do it on your computers. So you know, you saw my solution very briefly. I'm not gonna um go back and explain it just yet. We're gonna go ahead and have you guys try to do this one on your own, but we will go over exactly like how this works and kind of give you guys an overview. So has everybody found Thor? Go ahead and give me a thumbs up if you found Thor on Codingame and you're able to get in there. All right, so Keon's there. Fiorella, how you doing today?
Where this is at?
I'm sorry, what?
I was trying to find is this like later on in it? The
This
power
is
of
in
Thor or not yet?
this is in Codingame. Are you on the Codingame site right now?
Yeah.
Okay. If you go to search and you just do Thor, there should be the Power of Thor episode 1 should come up.
All right, I'm getting it right
All right. And Anayaka, are you able to find it? Oh, we have something in the chat here. Oh, Ayana had to go. Okay.
now. I found it. I was able to find it.
Okay. All right. So let's talk about the I'm gonna go ahead and play this first one here. So you're trying to direct Thor and you're trying to get into this um light of power where he can get his hammer. And he's drifting off in the wrong direction. So you know, it's not gonna work if I just use the default code which says print southeast. So it's not always going to be the right thing to do to send him southeast. You know, maybe that'll work in some situations, but it's not going to work in most situations. Um, so what we have to do is take the light X and the light Y, which is that's the target. It's going to tell us those two values, and it's also going to tell us his initial value, the X and the Y. And there's a coordinate system here. Maybe I can debug. Let me see if I can put this on debug mode. No. Okay. So I'm gonna just annotate then in that case. So this is the way that a coordinate system on Codingame and on most video games, the way that it would work. That's not very neat, those arrows. Let me see if I have better arrows. Okay, so this is 0, 0 up here. This is the point 0, 0. So it's 0 for X and it's 0 for Y. And then down here, this is as far over as it goes, which is let me go back in this map to see how far it goes. So it's 40 wide by 18 high. So then this point down here is going to be the point 39 and 17 because it starts at 0, 0. It doesn't start at 1, 1. And so 40 units, going 40 units to the right would take us to a cell with an X value of 39, not 40. Does that make sense to everybody? Why you know, we're not counting at 1, we're starting at 0. So that's why this is going to be less than the total length of how wide it is. Any questions so far, or does it make sense what I'm?
No, I get it. Yeah, because when you're essentially your 0 point is still a point. That's why still have to count it as a point.
That's right. That's right. Exactly. So we're starting there and ending here, and all the values have to be somewhere in between for the X and for the Y. So it's going to give us, in other words, it's going to give us some value here of our target. That's where we want to get to. And it's going to give us some value for Thor that's going to be like a starting value. And then we can give directions that are according to here, our possibilities are north, northeast, east, southeast, south, southwest, west, and northwest. So it's looking every round for us to give him some instruction on what direction Thor should head. So that's pretty much the game. It's a simple idea, but it's not necessarily simple to execute for somebody who's not used to coding. So I think this is a good challenge as far as like being able to conceptually understand, okay, I need to send this guy, in this case, I need to send this guy east, and then at some point he's going to want to go northeast, right? So that's the plan. But how do I get it to do that? So anybody got ideas on how to execute this?
It's going to be a whole lot of Elif.
Yeah,
statements.
if and elif. So elif being else if. So in other words, if that first condition is not met, then elif. So let's before we try to solve this and tackle that problem, I want to go to Python, and I'm just gonna, oops. Actually, I'm gonna clear my board here. Okay. So I'm gonna go to an online compiler here. And I want to talk about if and elif. So if I have an if statement, let's declare a variable, and it'll be an integer. And let's set this integer equal to 6. All right, so now I'm going to make some conditions. So if x is greater than 0, then do this, computer. That's what these colons mean. So if needs to have this, needs to end with this, and the line needs to end with this. So if this condition right here, this x is greater than 0, is true, then here's what I want you to do, computer. Oops. I didn't mean to do that. Okay. Then here's what I want you to do. And enter. So you see how this is tabbed because we're starting a new code block, and we want this to be what happens if the if statement is true. So if x is greater than 0, I want you to print x is greater than 0. And then elif x is maybe greater than 3. I want print x is greater than 3. And then elif x is greater than 5, print x is greater than 5. So what do you guys think is going to happen? Let's make a prediction. When I run this, what's going to happen? Any guesses?
Yeah, it'll skip the first two, and then it'll print out x is greater than 5, the last elif statement.
All right, let's see. X is greater than 0. So that went a little bit different to predictions. Why is that? What order is it going to execute this in?
Oh, because the first statement is essentially true.
The first statement is true. That's right.
So it ticks out, right?
Yeah, so right here, it ends the loop with this if statement because this statement was true. So it does not even look at these two because elif is only looked at if the first statement is not true. So this is all one conditional system here. And the first thing is true. And so it never looks at these other two. But we could have something kind of similar, which is just three if statements. So not using elif. What do you think this is going to print?
I would say all three.
All
Yeah,
three.
I think I see.
Let's run it. Let's see. Yeah, it printed all three. So why is that happening?
Because it has
I
the
would
if in
say,
the front.
oh,
Yeah, let's go. Fiorella, go ahead.
Oh no, I was just gonna say because of the if, because it's also another one that says oh, it's this as well, just like the first one.
Right. So it's not really caring what the result of this one was. It's viewing it as three separate questions, and it's answering each one in order, but it doesn't really care whether this one was true or not. It goes to this one and it answers this question without regard to whether this one was true or false. It doesn't care if this one was true or false because it's answering this question in isolation from everything else. Whereas when it was the elif statement, uh, elif makes it so that it's viewing it like this, where this is all one code block and only one of these situations at most is going to be true. And then you can finish these elifs. A good strategy for these is to have else and then print x isn't greater than any of these, something like that. So now what would happen when I have an integer like a -6? So I'm going to go ahead and run this. And now the else is going to catch it and it's going to say else isn't greater than any of these numbers 0, 3, 5. So, now it's catching that this else statement is catching all the other situations. So it's checking if this is true, and then it's checking if this is true, and then it's checking if this is true. And it's going to stop as soon as one of these is true, but none of them were true. And so it goes into this else bucket. And every other situation, if none of these were true, then this is how it's going to handle every other situation. All right. So this is a very common structure to how you're going to be organizing these situations. And you can do that with your um, Thor situation. So I realize it's probably not ideal to have a video just sort of, um, stop here. But I am going to go ahead and I'm going to just pause it here for the video. And I'm going to let you guys try to work on this and spend a few minutes coming up with some code. And then maybe in like 10 minutes or so, we'll check and see what you got. All right. So I'm going to pause it here. No, that's the share that I'm pausing. Where's my record? Pause recording. There. Okay, there we go. All right, I'm gonna share screen again and give a little bit more explanation here. So the values for the x and y are going to be changing according to, so like whatever Thor's. So I'm actually going to take off that initial. You can change these, and I'm going to take off that initial because it's not going to stay. It starts off initial, but that's not going to stay. The values. I'm going to be changing those values, updating his position each turn. So what I'm going to do is I'm going to say like if tx. So this is one way. It's not necessarily the best way to solve this problem, but it's probably the easier to understand. So if Thor's x value is less than the light x, which is his target, right? He's trying to get to the light x. Then, and if tx or ty is less than light y. So let's see what that would look like. So if his I'm going to kind of block this out and give my own scenario. So if Thor's position is less than light X and Thor's Y is less than light Y, then that's going to look like this, where here's Thor and here's the light. So Thor's X, let's say that it's 5, 5 for Thor, and the light, let's say that that's 20 and 10. So what direction should we be sending Thor?
To the right and then down.
To the right and down?
So
And what do we
east
call that?
and then south.
East and south, right? So we're gonna call that we're gonna say print southeast, because you have to put the north-south direction first, and then you have to put the east-west direction. So if Thor's X value is less than the light X, and if his Y is less than the light Y, then that's where you would want to send him. You would want to send him southeast. Does that make sense, Fiorella? Or was there any part of that that's kind of confusing?
Yeah, I just want to ask why the light would be down there instead of up, since it's showing it's in top, I guess you could say.
So yeah, that's why I blacked that out, because in the example that they started us with, that was, let me see where the eraser is here. Okay, so if you're just looking at it from this scenario, here's Thor, right, in red, and here's the light in green, and we're trying to get Thor to the light, right? So if that's the situation, then what would be, we're going to say Elif, because we only want to print one statement per turn, so we're not going to use if statements. We're going to use Elif statements. We're only going to have one if, and then the rest of the structure is going to be Elif statements. So Elif, and now what's this situation? Is what's Thor's XY coordinates compared to the light X, or the light's XY coordinates?
On where we would move, like the northeast, or which light?
We would want it to be northeast. So this is Thor, and this is light. And let's suppose I'll just give you coordinates for Thor here. Let's say that Thor is at 20 and 10, and we want to send him to 30. And is that going to be lower or higher? It's going to be lower, right? Because remember that this was 0, 0. And this was 39, 17. So the further to the right you are, the higher the X value is. But the higher you are, the lower the Y value is, because the very top is 0. Right. So I told you that was going to be disorienting. I know that's kind of a bit confusing here, but so when I'm setting up my Elif statement, let's say that I'm handling this case where Thor is below the light, but he's also to the left of the light. How would I arrange the conditions here? Thor's X value, is it going to be higher than is it going to be greater than light X, or is it going to be less than light X?
I'm sorry, can you repeat that?
Is TX greater than light X, or is TX less than light X?
It's less than.
Less than, because 20 is less than 30,
Yes.
right? So do you see where I got that condition from, Fiorella?
Yeah, from how the door light's less versus 20.
Right. Yeah, so now let's do, and I'm going to link that together with the Y situation because we're actually wanting to send him northeast, right? We want him to go up and we want him to go right. So what do I set this condition for here? This relationship of the TY and the light Y. So
Shouldn't it
T,
just be the same as the one on the left side of the and?
so what's the relationship between TY and light Y here? Is TY greater than light Y or is TY less than light Y?
It's less than.
So it's 10. So let's
Oh,
write this
oh,
out.
it's okay.
TX in this case is equal to 10, right? Light X in this situation is equal to 5. So when I'm setting up this scenario, TX is going to be greater or less than light X. I'm sorry. Why am I saying X? I meant Y. I'm so sorry. This is Y. We're talking about Y.
Yeah, TY is greater than um light Y.
TY is greater than light Y. Right. Because we're talking about a situation where Thor's X value, where Thor's Y value, right here, this 10 is greater than the light's Y value, which is 5. Right. So the way we're going to write that is if TY is greater than light Y. Print. What are we going to have it print? What direction do we want to send him?
Southeast? Or would it be the northeast?
It's going to be northeast because we want him to go up. So that's going to be north. We're calling that north. And we do want him to go east. So northeast. All right. So that's two of the situations. So we've handled now. I'm going to go ahead and clear this. So we have handled a situation where we need to send him southeast, and we've handled a situation where we need to send him northeast. So I want you two to try to get those next two directions. I want you to try to do this one, sending him this way, and sending him this way. So you need to have Elif statements with the conditions, and then what you're going to print if that condition is true. And we're going to pause it here for a second.
Okay, yeah, sorry, because I'm trying to get Zoom.
All right, so we're back, and they've had a little bit of time to practice, not enough. We're going to have to finish this next time. But I do want to draw everybody's attention to a few things. So one is that we've got this print SE down here. So let me find well, I guess we may not have a test case that handles this, but this is printing southeast each time. And when we look at his movement here, what we want it to do is print send us northeast, right? Or at least east maybe. So yeah, when we look at this, they're actually at the same y value. So we really just need to send him east, right? So we don't want to send him northeast or southeast. We just want to send him east. So this print southeast, we actually don't want this here because our instructions are all going to be in this if elif structure. So we have to make sure that we don't duplicate it with what was already printed down there. See how I got rid of that? This print southeast statement that it starts you with, you want to make sure that you go ahead and backspace that, get rid of that. All right. And then there's another thing that I want you guys to be aware of, which is that if you're having Thor go southeast, you need to update his position because he's no longer at the position that he was before. Now he's at a different position, and that position, are we going to be increasing or decreasing his X position?
It'll be increasing.
Increasing. When we send him southeast, we're sending him east, and east is going to increase his X position. So TX, we're going to do plus equals 1. What that's going to do is take whatever his TX value was, and we're going to add 1 to that. That's the abbreviation. It means the same thing as TX equals TX plus 1, but you don't want to write it out this way because that's kind of like a cumbersome way of writing it. So there's an abbreviation for that, which is just TX increasing by 1. What about the Y? Are we changing the Y?
No, he has the same Y value.
In this particular problem, he does because we want the Y value to stay the same as 4. But I'm talking about for this situation here where TX is less than light X and TY is less than light Y, and we send him southeast. So if we send him southeast, did his Y change?
Yes, it was subtracted.
So TY will decrease when he's going north. And I know that's counterintuitive, but when you send Thor north, you're decreasing his Y position. Because remember, 0, 0 is the top left corner. So the further north he gets, the lower his Y value is going to be. So that's correct, Keon. We are going to have to decrease his Y position by 1. All right, so this handles one scenario and it updates. This is how you update Thor's position. Remember how before they gave us initial TX and initial TY? And I got rid of that word initial because I am going to be updating it. So I don't want it to always say initial. I want to update that as TX and TY, Thor X and Thor Y. I'm going to be changing it. So that's why I changed the name on that. So I want you guys to see if you can solve the Thor puzzle in between now and next week. And hopefully you guys can make a little bit of progress with this, maybe solve all of the solutions. But if not, we are going to talk about it and we'll make sure that you guys get clarity on what you need to do. All right. Anything you guys want to say or ask before we go?
No, not right now. I'm still just trying to do this programming in C, which has been breaking my brain. So I'm gonna try to see if I can get to this.
Okay. Yeah. So, you do what you got to do for class in C, and then you can relax and have fun with Python.
I don't know about having fun. Yeah.
Not
I
yet.
do have
It will be.
I,
It will be.
I do have a question though. Can you
Okay.
please just re-explain the if and elif if you have time? I don't know if you have time enough.
Yeah. Yeah. I'll go ahead and just take a quick minute there. So the if initiates a question of, is this condition true? So I'm going to highlight this part right here. So if this condition is true, and then there's a colon where you're saying, I want you to do this, and it's going to do everything in the code block that is indented. So all of this is what's going to be done if this statement right here is true. Now, if it's not true, then the program will keep going and it's going to look at the next thing at this level of indentation. So if this is not true, then it's going to go down here to this line, which says Elif, which means that I'm continuing the structure of this. And if this wasn't true, then try this. If this condition is true, then here's the next code block I want you to do. And you can link together a bunch of these elif statements all at the same level of all at the same level. And, then you have do this or do this. And if none of those are true, then you can finish it with else. And all of these are really part of one single conditional structure where only one of those will be true. Because if this is true, then it stops right there and none of the rest of those are even looked at. If the second one is true, then it doesn't look any further. It just stops at what the second one is, if that's true. And so on. Did that answer your question, or was there a specific thing that you wanted to find out about?
No, so yeah. What's really like tripping me up is how we want the if statement to go through, right? And if it is true, it kicks us out the loop because it's true now.
Right.
If the
Right.
first if statement, and if he's not in the location that he needs to be in,
Mhm.
it's still going to kick us out the loop. So it's not going to continue the other elif statements, which
that's right.
still need.
Yeah, it's not going to continue the other elif statements, and we don't want it to, because for each turn, we're only giving one instruction every turn. Remember that this is all taking place within a game loop. So we have while true, and this is indented. So this will continue until his position is identical to the light position. This code block right here below while true, this is going to continue happening over and over and over again. It's going to update us with the remaining turns, and we have to collect that information. We don't have to do anything with it, but we do have to collect that information. And then it's going to proceed to the if statements. So we do want it to continue doing that over and over again. You're right. But that's being handled by a while loop that's not being handled by, because we're not going to be able to get him there in one turn. We have to do this we have to check it over and over every turn, updating his position. And eventually he's going to get there. But each turn, we only want to provide one line of command.
Yes, and I understand that. So like what I'm thinking of is when we go through the loop, we update his position and we keep updating his position. And let's say that the if statement is the first position that gets updated, and it's true, it becomes essentially true, but he's still not in the right spot. Even though we're gonna go through the loop, it's still gonna say that first if statement is true, and it's still gonna skip the rest of the elifs. And
So
never
you're saying
update his.
once he's on the light, is that what you're talking about? Once he's arrived at his destination?
Hold on, I think I'm seeing what I'm wrong at now. Because that first if statement, that's gonna make it all the way true. That means he's on the light, essentially, for that first if statement. If the first if statement is true, that means he's on the light. And
No,
if
that
he's
would be
not
if they're
on the light,
equal. No, that would be if they're equal. So if Thor's X value is equal to the light X, and if Thor's
and the Y. So
Yeah.
essentially but for that entire if statement, just that block right there, for that entire one,
Yeah.
that means when both statements are true, the light X and the light Y, that means he is on the light, which it doesn't need to continue the elif statements and add to positions.
So if he's on the light X and the light Y, then this will be false, because notice that I don't have less than or equal to. I have just less than. So this only triggers if it's less than the light X and less than the light Y. So this won't trigger if he's on the light.
Okay, I'm getting it now. Yeah, that was the part that was tripping me up though.
Okay. All right, cool. So I'm going to let you guys keep playing with this, and all of these puzzles that I'm showing you, I could solve them and show you in, just like 5 minutes or less how to do it. But when I was first trying to do this puzzle, it did not take me 5 minutes. It took me more like 5 hours. It was like, it's a really time consuming process to think your way through these problems. And so I don't know about, this particular, I don't know how long this particular puzzle took me, but the point is it takes you a lot longer to figure out than it does to implement. So once you know the solution, it's just like a crossword puzzle. Like once you know what it is, you just write in the answer. But trying to figure out what that puzzle is having you do and how to get there, it is a very time consuming process, and it is a very challenging process. So stick with it for a while, give it some time, and I'll see you next time.
All righty, thank you. Have a good one, Jesse.
All right, you guys too.